Hi, everybody. Good morning. Thank you for joining. Good morning, good afternoon, good evening. I'm all around. Love a lot of interaction today. We're going to try to make this as conversational style as we can. Any questions you have, please put in the chat. Love to hear where you're all from. If you want to say hello, good afternoon, wherever you're at, wherever you're from, I'd love to see it. Love to get that feedback. So, my name is David Moss, NGS. Have with me today as well Connor Ferguson, Whisper Systems, enterprise drone manufacturer, a lot of different things we're talking about. And we have Leo. Leo's been in the LiDAR industry for many, many years, 10 plus, working with a bunch of names, such as Green Valley, GeoSlam, and now Inertial Labs, so last year and a half. So good morning, everybody. Looks like we got some people from Omaha, SoCal, New Jersey, Sarasota, Florida, Missouri, San Antonio, all the way in India, Alaska, South Carolina. Grand Junction keeps on coming in. Love to see it. So Connor, if you want to take the floor.
Yeah, I'll go on and introduce myself. I'm Connor Ferguson. I'm the CEO of Whisper Systems. We're a commercial UAS manufacturer, and LiDAR being one of our main focuses. So I'm going to share my screen. Is
Oh,
everything
that's
showing
a
up
lot
well
of
on your
faces
A
part?
lot
real
of
quick.
friends coming from all over the world. I see a lot of familiar names. Hello, everybody.
We even got an Antarctica. Hope that's real. That's pretty cool.
Is my screen showing up good?
Yeah, let me put there. There we are.
All right. So we'll get started. So a lot of what we'll go over, I wanted to go over today was more or less our drone and a little bit more into the mission planning and kind of the appropriate way to do this. So we're going to start. We make this is kind of our standard drone for LiDAR, the Whisper Ranger Pro, and our mission planning software is Whisper Ground Control. We've got a real, we support many LiDAR systems, but we've worked really close with the Inertial Labs to have a real tight integration with that package. Uh, we do have stuff coming out in the future where you can control the LiDAR via the hand controller, share GPS from the drone to the LiDAR, and just have a tighter integration to make it a seamless, easy operating system for that particular LiDAR. And um, Inertial Labs has been great with working with us to make that happen. So it's nice to have LiDAR manufacturers work well with UAV manufacturers to kind of make an easy button kind of approach to using these high end and mid level to high end LiDAR systems. So the first thing I wanted to go over was uh, planning mission, kind of the factors that you have to look out for. Uh, AGL, your height above ground level. Uh, it makes a big difference on what you can penetrate through as far as heavy vegetation, light vegetation, things like that. The selected LiDAR sensor, depending on your LiDAR sensor, will tell you your accuracy range, which will also kind of go back into that AGL, how high you need to plan your mission, depending on the sensor and the area that you're surveying. The speed of the mission, so how fast you're flying that mission. You really got to really needs to be around 5 to 10 meters per second, depending on what your ground looks like. Is it a bunch of trees or thick vegetation, or is it just open field and grass? I mean, those are big factors as far as that goes. Your overlap, basically your overlap of the swath. So, and if you're looking at it in terms of photogrammetry, like your side overlap is really important. The more overlap, the better penetration is kind of a key, but there are kind of standards we stick to there. Then the type of project you're doing, is it vegetation encroachment on power lines, or is it topo surveys over a field, and terrain and vegetation? And these are kind of the main factors that you have to look out for when planning a mission. So we're going to start by going over the mission planning for mapping. In heavy vegetated areas, 50 to 70% side overlap is generally your best bet to make sure that you're getting a good enough penetration under that canopy. The altitude is dependent on the sensor, but say if you were going with recipe XT32, you would want to be somewhere between 165 feet and 300 feet. But in terms of heavy vegetation, you're probably better off 250 to 165, depending on how thick it was. And 5 meters per second is basically the basic speed that you want to fly to really get a good penetration under heavy vegetation. For like mid vegetation, maybe, trees, but not as thick as like the jungle in South America, 50% side overlap is good. Again, the altitude's dependent on the sensor, but you can fly anywhere from 5 meters per second to 10 meters per second. For low vegetation like grass, you can do 10 to 30% side overlap. Altitude is dependent on the sensor again, but you can go fast as 10 meters per second and still collect good data. For corridor scans, I broke it into 2 sections, just kind of the main applications, what we deal with currently. For like roadway inspections and topo of roadways, you want a minimum of 3 flight lines down that corridor. We suggest 50% side overlap. The sensor, depending on how much vegetation, kind of goes back to the altitude, but generally you can go as high as that sensor will allow and still get good penetration over corridors. If it's a roadway inspection, doesn't apply to power line or fiber. 5 meters per second for best results, and 10 meters per second for average results. For power line and fiber mapping or inspection, 2 to 3 flight lines is good, 50% side overlap, and then you want to maintain a height of within 100 foot of that tallest power line or fiber line, depending on what you're looking at. And then again, 5 meters per second to 10 meters per second is the speeds you want to stay at. So quickly, we just go over our mission planning and how we have it set up, knowing these factors. When you start, you have your mission start where you can select your waypoint altitude and then your mission speed. And those little red arrows are pointing out those where you input those numbers. Then after you plan your grid, you can select the overlap. Some of that is applied to photogrammetry, but the side overlap is really the main thing that you're looking at. But generally, whatever we change the side overlap to, we change the front overlap to as well. You have, for tough areas like mountainous areas, you really want to use terrain follow. So we have terrain follow, and we adjust the tolerance depending on how tight we want to follow that terrain. And then when you start your mission, it gives you the option to run an auto LiDAR calibration. So you just slide the slider and it will auto calibrate the sensor and then continue your mission. And so it'll be similar to this, flies a straight pattern up to 10 meters per second, then does a figure 8, and then goes straight into the mission after that. And as it returns back from the mission, it does another full speed straight pass back to home to kind of excite that IMU prior to landing. So that's kind of the basics of mission planning. with our system. So now the software name is Whisper Ground Control.
All right, I see. Connor jumped right in that, and that's good. I don't know if first of all, just say hi to everybody. I see actually a lot of familiar names. Hi everybody, and to those in Sacramento, and I lived there for 3 years when I was working for the U.S. Forest Service. 3 years, Midtown Sacramento, very nice, and to also Embry from Alabama, Roll Tide. I know it's gonna upset somebody, including Connor, but Roll Tide. All right, so I don't know if anybody has any question for Connor regarding everything he just talked about, and feel free to pop in the questions anytime. But otherwise, if and I'll just pick up from here. So my name is Leo. Yes, like David said, I've been around in this business for a very, very long time. I know most of you have participated in a lot of different webinars these days. Tons of good information from everybody who's doing a great work, helping this industry, helping the community. I only have good things to say about them. But for myself, I came from a little bit. I got my master in geography from University of Alabama, and my technical background is in actually multispectral and hyperspectral remote sensing. So I came from the user side after spending many years doing mapping for the U.S. Forest Service in the Pacific and Northwest region, basically covering everything, from Hawaii to all the U.S. affiliated Pacific islands in the West Pacific region. And I always think from more from the customers or the operator's point of view, and just want to make sure the products we produce are as reliable, capable, and easy to use as possible. Obviously, it's a long way to go, and I see some questions coming in. Connor, feel free to pop in and answer. And again, for my session, I really want to keep it more conversational, I didn't even prepare a presentation or slideshow or anything, but I had tons of data and images on the site. In case you have any particular things you want to discuss and look at, let us know, and I'll try to find something to show you. But the question is: the device storage on the drone stored LiDAR information, or is sent to another device during flight? Excellent question. For the LiDAR side, everything. So the raw data the system's capturing includes obviously the laser scan, the camera images, if you have a camera module, and then you have the raw GNSS and raw MU data. For Recipe, for example, as Connor showed, all the raw data are actually zipped up and written in a proprietary format, data, into an external USB thumb drive that's plugged into the payload. So everything's done in real time. So the advantage of that is once you finish the mission, you can just unplug the USB thumb drive. You're good to go. I hope that answers the question. So there's nothing, being sent to anywhere else during the flight from the LiDAR payload. So yep, right there, everything is in that USB thumb drive, and the drive comes with the system has a 256 gigabytes of storage space, which is a lot. And so I hope that's a good question. Other than that, I kind of want to start by covering a little bit about, since I've been with this industry since pretty much day one. I'm not sure if you all are interested in the history. So 2023 is interesting. 2023 is almost like, the exact 10-year anniversary for drone LiDAR. LiDAR has been around for a very long time, starting with, the research community and the military. The first time I dealt with a LiDAR data set was around 2008, 2009. The data was specifically from the U.S. Army for topo mapping for the island of Guam, for the entire island of Guam. So the first time I saw that data set compared to everything else that was available back then, it was absolutely amazing. That's when I was hooked by the LiDAR technology, getting the up-to-date topo, how easy it was. Even though back then it was the large aerial platform, If some of you ever worked with the aerial data set, it's very different from what we've seen today with the drone system. So about 2000, 12, 2013-ish, so that's when the first drone LiDAR system came into the market. It may be debatable which company actually put out the first one to the market, but it doesn't really matter by now. So, from 2012, 13 to about 15, 16-ish, that time is what I would call like the first phase of drone LiDAR adoption. And as you can imagine, the systems back then were very expensive and not very easy to use, to be honest, and not very reliable either. But that's where it started. But then from 2015, 16-ish to about 2019 and 20, that's what I would call the second phase. That's when kind of the market was a kind of a proven by the first movers, so to speak. So now we have more providers coming in, but the fundamental technology didn't really change. The same idea. You get a laser, you get a camera, you get a pose system in the middle, and data logger. The algorithms are very similar, between one to another. But now you see more providers coming in. The price was still very, very high. And if you remember, just 3-4 years ago, if you want to get a reliable system, you're probably looking at 100K to start. Anything below 100K, you would question whether it's good or reliable. What's interesting is the stage we are in today. I think a lot of you may have questions popping up, but please do not hesitate to ask. 2019, 2020 is a pretty major watershed moment for drone LiDAR industry. Now, the real big disruptor, so to speak, it was, let's face it, it's DJI coming out with L1, together with M300. It's a critical moment in our industry. And one thing, the availability of that L1/M300 combination, because of its much lower cost and friendly, at least eventually, the UX and I would say almost completely changed the psychology in the marketplace from the customer's point of view. And before that, there were companies trying to bring down the barrier by, one of the major barriers was cost, trying to lower the cost and selling systems at lower price point. But if you remember back then, again, even if somebody tried to sell something at a lower price, customers tend to not believe it. The issue was it's probably not good enough. But once DJI came out with the L1 M300, I wrote an article in 2020 actually about this, and as expected, the psychology of the marketplace basically completely changed. The expectation back then, before the watershed moment, was, what? Unless it's 50, 100K, I don't really trust this. So there's that. But after that, today, I think many of you would agree, the expectation is, what? I should be able to get something that's good enough that doesn't cost me an arm or a leg. And what is that price point today? I mean, it's arguable. Some say it's 50K, some say it's 30K, some say it's 20K. But the psychology in the marketplace completely changed. It's really helpful to drive the adoption forward, but at the same time, it's causing a lot of problems as well, being so many more and more extremely low-cost systems coming to the marketplace. Some of them really don't perform and disappointing a lot of new adopters, which in turn really hurt the industry as a whole. And also the questions that we see as manufacturers in the marketplace are changing dramatically. I mean, before, 1920, the questions were still mostly like, hey, does this work? How does it work? Right? So you have to spend a lot of time helping potential customers to understand those questions. But today the questions, from most inquiries are different. The inquiries coming in with a sufficient, really good understanding based on all the great information out there on the web from everybody. Again, thanks to everybody helping this community. The questions today is like, I know this thing should work, so tell me, what is any difference between yours and that, and what is the best offer you can give? So it's highly dynamic. There's so many options out there in the market today, and besides the big names and new names coming in, just every year, and so the options are abundant. Many of them are actually quite capable, but not every system is built the same. Even options from the same company. So it's a new time. It's a new age in the LiDAR space. And so I'm pretty excited, and being with the industry since day one or prior to the start of drone LiDAR, and watching how the market changes, how the technologies and evolves. Great questions coming in, Drew. And so and I want to start with that general introduction of the history of the marketplace. And another quick thing about Initial Labs is, yes, we are Initial Labs. We're headquartered in Virginia. We are in Leesburg, and I'm the only one actually who is based on the West Coast. I'm meeting you all from Berkeley, beautiful Bay Area, and I'm the only one out here. Everybody else is in Virginia. So we are, if you can, hit our website, it's initiallabs.com. You'll see what's our main business. Initial Labs, is primarily the core competency is navigation. And we do a lot of, we are primarily US business focused, and some DoD as well. We are hardware manufacturer basically at core, being around for 20 plus years. And everything is, all the systems are manufactured and supported out of Virginia and shipped from Virginia as well. So any questions about that, please feel free to ask. So with that, like I said, I want to keep this conversational. If there's any question about anything, feel free to ask. I'm going to try to address. So I saw the question is, any tips or tricks about power line mapping. That's perfect place. And I also want to show you a real example of some of the things when it comes to mapping power lines. Let me share my screen real quick. Like I said, I have tons of sample data and images to share if you want to see anything. And just let me know. So this is an example of what you can do with a drone LiDAR when it comes to power line. I hope my screen is up already. So this is an example of some power line facilities we recently did. And credit to AEP Energy, and this was done in Columbus, Ohio, at a training facility. This is kind of a pretty good example of what you could possibly do with drone LiDAR for power line. You can see with this system, again, this system is M2X, Recipe M2X, and it was able to capture rather well most of the assets, including the connection points, contact points, even guy wires, some of the smaller lines. And the trick about flight planning for those lines is really, this is something that's going back to oh, can you see my screen? Okay. All right. I hope this is up now. Can everybody see the screen now? Okay. So you can see, that the key is going back to something more fundamental, and those are the things I actually like to talk more, is understanding how actually the system works. In this case, you're looking at two sensor data capturing sensors from your perspective. One's a laser, other one's camera. I think on the camera side, it's easy to understand. All right, so you want to make sure all assets of interest are actually within the field of view of the camera. So, for example, the Recipe with a 16 millimeter lens on board, your field of view after calibration is about 70, somewhere between 70 to 90 degree. It varies a little bit from system to system, depending on the calibration parameters. So you just want to make sure that all the assets are actually within the field of view. This is typically not too much of a trouble for power line assets, especially and except when you're flying low and when you're trying to capture those tall assets vertical, like the tower, the pole. You want to make sure all this, all the sides are captured. But the camera, the field of view, otherwise is mostly a little bit of a concern when you are flying over a larger project site with, again, tall features like trees. If you don't plan it carefully, you possibly can miss some of the tree tops. But otherwise, for the laser, now here's something interesting. I know there are people out saying it's easy, just fly and it should be fine. But no, that's not the case. From laser to laser, the behaviors are very different. The capabilities of lasers are very different as well. And so I'll use a few examples. Now, for example, the Avia. The Avia is very smart to focus all the laser pulses within the 70-degree field of view. So as long as you make sure your flight paths actually, first of all, your flight paths need to follow the line, not perpendicular to the line. Usually you do one forward, one back. Sometimes you want to do another one, but maybe not necessary. So you want to make sure those lines are captured within the field of view of the laser. Besides that, there's something critical to consider is the way the laser behaves. The laser has to process all the return signals on board, and because the laser actually, when it shoots out from the sensor and come back along the way, it can hit a lot of targets, right? If you visualize a beam going out, expanding itself along the way, that pulse can hit multiple targets. So the lines, it is like, it's probably one of the return signals, but then you also have other things. And if you visualize a vertical waveform from that bounce back, signals, the laser has to decide, okay, is this peak an actual signal or is it noise? Because there are multiple peaks. So that goes a little bit tricky, and we don't really exactly know how the laser companies actually process that. But you can see my whiteboard. I have something here. You can see the spec sheets, the strongest first to last, the strongest second strongest from laser company to laser company is different. From everything we know so far, there's some sort of at least with the Avia, Hesai, and other auto grade laser. And again, we are looking at really two classes of lasers: the auto class and the classic survey lasers built for survey. That'll be Teledyne Optech and Regal. But everything else, there's some sort of a magic number. It's somewhere around 40 to 50 meter right there, regardless what's that published maximum detection range. So that 40 to 50 meter range from the sensor to that target, in this case the power line, is where you can expect a good return of those lines. Somehow beyond that range, for most of these lasers, the lines are likely to drop. You're likely to miss some of the lines. So in terms of mission planning, besides setting up that flight paths, the direction, one or two paths, some overlap, and then you want to make sure the distance from your system, that laser, to those lines you want to capture needs to be, within that range. And obviously the closer, the better. That's always the case. So that's a little bit about a power line capture. But if you do it right, this is what you could possibly get with a good LiDAR system. You can see it really captured most of the assets are pretty well. I hope that answers the question. How does the loss of GPS affect the capture? Oh, that is an excellent question, Jennifer. Yes, it has a significant impact. And so there are two types of the laser mapping technologies today, actually three types if you count the static, the tripod-based static scanners, but we're not talking about that here. One is navigation-based, the other one is SLAM. So SLAM solution does not need GNSS at all to work. So you don't have to worry about that. But look at the drone systems, even though you can fly some of the SLAM systems like GeoSLAM or HoverMap, but those, I would have to say, are not really built for any large-scale real survey or mapping type of projects. So navigation-based LiDAR solution, GNSS is one of the fundamental input to generate your good data and accurate data. So the technology, the way it works, it starts with the trajectory. Building that trajectory and as accurate as possible is where it starts. Once the system, you are able to generate that trajectory, your flight paths in this case, accurately, then the rest, the next step is really about translating the laser pulse position from that target point, based on its relative geometry to that trajectory at that timestamp. So that's based on distance and angular measurement. So once you have the trajectory and you have a measurement, you understand the distance to target and the angle that, this is based on the orientation. of the system itself and the geometry of the laser at that time, you can actually know where that target point is. So the loss of GPS, if it's just here and there a little bit, just occasionally your processing software should be able to handle it, and it may not have significant impact even in the final results, because today some of the software like the IE SDK we use and it can do a really good job, because the IMU kicks in to help out and to fill in those gaps if it just like blip blip blip. But if you have extended period of loss, GPS signal loss, and your mission is likely to fail, unfortunately. So when planning mission, you want to make sure, yes, and your system needs to get as good as possible GPS signal throughout that mission. That is very important to get the best results that you would wish to get otherwise. And so that's for that GPS question. And this also goes to your base station is very important too. And most drone lidar system navigation based still relies primarily on PPK, not RTK. So you want to make sure that is as solid as possible, as accurate as possible. Yeah, John. Hey, John. Yeah, SLAM. Yes, I'm a huge SLAM fan. Actually, I believe in the long run, SLAM is likely to be actually even bigger than navigation-based solution. But really, the future, in my view, again, is sensor fusion. It's SLAM with navigation. VSLAM, LiDAR SLAM, all these technologies fused together to provide this, really one solid solution that can handle different use cases, different situations. And I even made a video like 4 years ago discussing SLAM myself. And that's a question to the GPS question. I hope that's good enough. I'm an energy, battery and new to LiDAR collection. What's the maximum slant angle to get optimal collection in the oblique? Well, that is really good question, Joe. Thanks for the question. Now, this one is a little complex. That most of the lasers in the market today are 360 scanners, but they are more and more tightly focused, like downward looking lasers. So for those downward looking focused lasers like the Avia, some of the Regos, and it's what you have, and you might even have to take out a few degrees. Like in the case of Avia, based on our observation analysis, you do want to take out about 2 degrees on each side, maybe even a little bit more, because for some reason, those outer strip of that laser return tend to be noisy, not accurate. But for other 360 scanners, there are 2 things you have to consider. And general guideline is 35, 30, depending on the manufacturers. And they'll say, to the left, to the right, 30 to 45 degree, of either side, as you get somewhere, between 60 to 90 degree field of view altogether. But it really depends on what you want to do and actually how good that your system it is. The concern of not using those very large incidental angle scanner pulses is because your accuracy and precision will drop, because of both, the longer range to target. As you can imagine, there's a laser precision curve. The longer it is to target, the laser measurements on intrinsic accuracy and precision will both drop. So you're losing data quality already. Larger angles, it's a longer distance to target, unless, again, you're scanning some facades like building sides. In that case, your distance could be even shorter. And the next thing you have to consider is, it's an angular measurement accuracy, the laser's rotation, its encoder, is it accurate or not? Then your system's IMU accuracy, is that give you that accurate enough understanding of your orientation of the system yourself? So you're basically compounding all this, different error sources together. That's what's going to determine the final data accuracy. So this is looking at this, different settings based from the accuracy's point of view. But if you're not too, and also there's another one often overlooked is beam divergence. So if you look at this flat surface, you have a laser coming in from slant angle. the beam goes out like this, right? So if it goes out at a large angle, and the laser beam is going to expand a lot more. So that in itself will introduce error also. So exactly what that error is, it's a little bit complex, and you can't actually mathematically model it out. And I've calculated for myself to get that number. But yeah, so depending on project, depending on your exact AGL and everything, you can draw a little chart and try to understand. And your target or required project accuracy and precision, it may or may not matter that much. You can possibly really increase that slant angle. And for those 360 scanners, by the way, if you do want to capture the building facades, the walls and everything, and also the things like the tower, the poles, you want to capture the full structure. And if you want to capture, for example, the tree structure, internal structure, under a canopy, those angles is actually what you need, unless you rotate that laser itself and face it, target it, which is I wouldn't recommend these days. So you would actually, in those situations, you actually need those slant angles. So there's no fixed answer, but the simple answer is if you're doing a simple topo mapping, flying at 50 meters above, yeah, typically somewhere between 60 to 90 degree, you should be good, assuming your system is accurate. Can this, well, depending on the metal, right? So, but I would say general questions. Or if it's just capturing, let's say, a pile of metal, yes, you can. But you have to be a little bit, probably needs to understand the project itself a little bit more to understand, what exactly you're trying to get out of that scan, actually that point cloud, in order to really understand. Everything is actually project to project. I would use this opportunity to say, if anybody tells you, yeah, this one system, this one workflow should handle all the situations, everything you can think of under the sky, I would say no. There's no such thing. And every project is different. Every system is different. You do have to, it's in your benefit to learn a little bit more about how this technology actually works, in order to actually make sure your result actually matches your expectation. And beyond that is getting more out of the system, because general guidelines, rule of thumbs, best practices are all based on certain use cases, but there are things you could do with the system that are possibly outside of those guidelines, but you should be fine. As LiDAR is more, yes, thank you very much for the question. Keep them coming. And, again, we want to keep this conversational, and this is our first one. We're trying to figure out how everything works. But my personal preference is always keep the conversation, trying to answer questions that you are most interested in, you care about. It's about you. It's not about us. So I want to make that good. So as LiDAR is more subject to weather condition adjustments. That is a fantastic question. There are multiple, many different layers of answers I could provide about this. Yes, both drone and the LiDAR are affected by weather. This includes clearly rain. I would not recommend anybody to perform a LiDAR mission in a raining day, even though I know there are commercials out there showing, yeah, this thing, flies or whatever, does whatever, with pouring rain or whatever. Please don't do that. It's not recommended. When it rains, you should land it. It's for everything important. And laser itself, by the way, unless it's a bathymetric LiDAR, green laser, the near infrared laser, either at 905 or 1550, and they're going to be absorbed by water. Water is your number one enemy in many, from many perspectives. So, and even if you capture some data, it's going to be super noisy. All the raindrops are going to give you all the noise points in the air. So, and your measurement is unlikely to be optimum. So don't do LiDAR mission during raining condition. And also windy days, wind may affect your data accuracy besides accuracy, safety. Again, strong wind is always a challenge for drone systems to handle in itself. But one thing interesting, sometimes if you've done a lot of LiDAR projects, you will see, because there are high winds, up in let's 50 meter, 100 meter above the ground. We don't really know. One thing that could happen is while we see the drone flying smoothly in the air, looks like everything's fine. But if for some reason the systems got hit by a sudden strong little bit, whatever that may be, that can cause the drone system to shake by itself. And those little shakes may have a negative impact in your data accuracy. You will have the data, but your accuracy may be lower. So that's something to watch out for. So if it's super windy, obviously you don't want to fly anyway. Yes, humidity. Thank you, Josh. Yes, it's the same idea. So the best condition to fly a LiDAR data, this is for, it's no wind or calm day. And also, I'm saying the ideal condition to fly LiDAR data to get the best possible both point cloud and then colorize the point cloud. If you need that best possible colorization is overcast day. That's, if you're a photographer, the good reason for that. So a calm overcast day is typically, your best day. But I know somebody will raise this question. Overcast will affect your GPS signal. Yes, it will. So it's a lot of, depending on what you're looking at, but definitely avoid performing missions in a rainy day or strong windy days and things like that. Dual frequency laser, one of them being green. Well, as this is an interesting question. And last year, we actually was investigating bringing a bathymetric, actually dual use case LiDAR, bathymetric, bathy and land, survey LiDAR to the US market. We have a partner in Japan that actually use our INS inside the system. It's positioned as a bathy LiDAR. But that system can also be used as, for mapping over ground. The problem there is, as you might know, that typically the green LiDAR systems are very expensive. And they're not too easy to use, but yeah, they're out there, and I'm sure there will be more options available in the next several years, making that solution more affordable. So that's that answer. And any other questions?
We do have a bathymetry solution at Whisper using UGCS dual frequency echo sounder, and it does work well. It's got a 200-meter range, and we've tested the bathy LiDARs and didn't have much success, but with the dual frequency echo sounder that UGCS offers, it worked great. So
yeah, so again, we'll keep this composition. I don't know if my screen is still shared. David, is my screen still shared? If there's no other question to answer, I will show another example. This goes to a question is, okay, and as I said, not all systems are not built equal. Even all recipe system, depending on the laser and GNSS receiver you use, it will have different capabilities. Here is an example. We're looking at the two very popular lasers these days, the M2X and the XC32. Both are really good systems. I know the XC32 is the most popular laser actually probably in the market today. But let's look at this thing. What we did, again, thanks to Connor and team, they flew this comparison. The systems, the payloads are carried by the Whisper Ranger Pro. And what you're looking at here is looking at the quality of the data from different angles, between these two systems at different AGL. The speeds are all the same, I believe. Connor, correct me if I was wrong. I think this was at 6 meters per second. But the AGL AGLs were different. So on, for example, in this one, on the top row.
Second.
Okay, top row, we are looking at the topo result from the M2X system. On the bottom row, it's the result from the XT32. And the AGLs we're looking at is 50 meter, 100 meter, 150 meter. And the site itself, it's important to point out, the site itself is heavily vegetated here. As you can see in this example, it's a lot of trees over this. Then the question is, okay, what can you get from those two lasers? Everything else in this case, in this study, was pretty equal. But you can look at this. At 50 meter, there was no difference, right? Both did an excellent job. Even at 100 meter, this is really interesting, right? So keep in mind, in case you don't know, the maximum detection range published by Hesai for the XT32 is 120 meter, right? So typically, like with the Avia, the published maximum range is 450 meter. But that laser, you don't really get anything. You can forget about it after 150 meter. But even with that, after 50, somewhere between 50 to 70 meter, the precision curve starts to behave very strange. And if you want high quality data, you probably don't want to fly that laser beyond 50 and maximum 70 meter anyway. But look at this performance from the XT32. Even at 100 meter over this site, it did a really good job. This was a huge surprise to me as well, because I was expecting this to start dropping ground points. But again, this one example doesn't tell you everything. The forests you're looking at may be different from this example. It's very project to project and site to site. We, us engineers, sometimes say, is there's only one way to find out if it's going to work or not, is actually do it. But by 150 meter, as you can see, if it's open ground, this is even bigger surprise to me. Is 150 meter was way beyond the published max range from Hesai for the XT32. But you look at this, in the open ground, it was really good. But where you had dense vegetation, yeah, it's too much for it. It can't get you anything. And so, this is something you may want more example. You look at this ditch here. This is a situation when you are choosing a system. I need one system. Which one do I get? Again, there is no one system fits all. You do have to investigate. For my project, I typically do X, Y, Z. And if you are starting a business, you're thinking, I need to make sure I get my ROI in the next, 12, 18 months or whatever. And these are the type of projects I typically do. You do want to make sure you looked at everything. Not all systems can be the same. And just simple physics, it just can't do it. And again, if anybody tells you one system does it all, you probably should just walk away. And so, okay, next question. In a sense, great. We got questions keep coming in. Compare power line capture to telecom. Oh, this is a good one. What is the start of a LiDAR for smaller? Yeah, so that's an excellent question. Let me try to find an example and to show you. That's always the best thing to look at. Let me see. Let's go back to, we have done actually quite a bit of investigation, and we're working with major utility companies today and really trying to find out the limits of different lasers. What I can tell you right now is, if the best performance, best result you're going to get, that's still be coming from those big lasers. That would be the Teledyne, for example, the Teledyne CL360, or the big Regos, that's for sure. But otherwise, and I would have to say, we are about to launch the Ouster, by the way, Rev 7 OS 164. That's a very good laser. We are still investigating how to maximize its result, but so far, otherwise, the best result in terms of capturing the smaller features, it's the XT32 and M2X. They both do a similar job. The difference between these two, and the M2X is actually lighter, smaller, longer range, and triple return. So that's all advantages. One thing we do notice, full disclosure, those who know me, can probably verify this. I always tell you straight up, is there's no hiding it. So one little thing we notice about M2X in this case, you can see it's a little bit fuzzier than the X32. So that may have effect on capturing those smaller features. But if you get close enough, you should be able to, again, once you get close to about 30 meters, 35 meters, let's say 100 feet ish to those assets, the XC32 actually is quite capable of capturing most of those features. Now, whether the definition of those features are precise enough for a specific project, that still needs to be investigated. But it should be able to capture those assets and let you know what it is. But if it's precise enough, it's, again, test it. So that's for that question. What business can do with the LiDAR data? What data it provides customer? How they would interpret? Oh, yeah, okay. That's a very popular question. Thank you very much for the question. What LiDAR can do, and I typically, my answer is super simple. Typically, is anything that involves capturing the 3D, anything 3D from the real world, LiDAR can do it. Is a good option or one option to consider. That's what I often see is, people ask, what do you think? What's the future for a LiDAR solution? Is it going to be a big enough market or not? My answer I would say, LiDAR is likely to, some sort of LiDAR mapping survey tool is likely to be as popular as GNSS receiver, or as we see today. So that's how popular it should get. So what data can do right here is a good example, and I know the names I know already in the list are coming from this industry, that they can give you much better answer to this one. But for utility, for example, besides the mapping of the right of way mapping and as built inspection, but there's a big one in the power line industry today is vegetation management. And for example, for us in California, we have huge forest fires every year. And one of the major causes of forest fire is, tree falling down or wind, blowing down an old pole or something, causing live wire hitting dry grass and ignite a fire. So for vegetation management, it's actually really interesting. One thing you want to avoid is, for example, trees growing into those lines, or tall trees fall down will hit the wire and cause problems. So in order to detect those hazardous points or danger points or whatever, and you need to understand the geometry between the tree and the line features. So right there is understanding that geometry. In this case, some may argue, but I would say LiDAR is probably your better choice for that mapping, for that detection. Once you have a LiDAR point cloud accurate in this case, it may not even need to be super accurate. I mean, it's close enough to give you that geometry. You can very easily actually detect those danger points. That's a good one. That's a lot of value in that, versus traditional way of sending a field crew out there trying to, walk the line, trying to find where there's a problem. And the topo mapping is a great one. I think many others have talked about this. Topo mapping is still the number one use case for drone LiDAR. There are tons of researchers out there and manufacturing publishing white papers just to show you the advantage of using drone LiDAR versus other methods to capture topo. And so that's a good one. And a lot of new adopters coming into the industry are probably thinking about that use case. I'll get a drone, I'll get a LiDAR, I'll start my business, capturing point cloud for the surveyors in my county or whatnot. And other than that, emergency response is a big one. And for example, in Japan, a good use case is after a natural disaster, if you want to survey quickly what is that damage, and LiDAR combined with high resolution imagery is a very effective way to give you the quick, very timely assessment of that damage. And then volumetrics is another one. Construction site, for example, typically like how much dirt you dug out, and for business, a project manager, something you have to consider is, okay, how many trucks I have to arrange to come in to move everything out or move whatever in. So LiDAR point cloud is gonna give you that really accurate and fast result, and you can do that day and night. By the way, and a photogrammetry is not a great one, but you can't fly photogrammetry, when there's no light. So LiDAR, you can keep that flying and give you that quick result. Well, there's so many questions. I'll try to keep up. I hope that's a general answer, but there are many other use cases. And so the big question right here, what information can be derived from LiDAR data? I've spent a lot of time modeling point cloud and still can't find anyone who can tell me exactly. Okay, so we just look at an example is a topo. So once you have the LiDAR point cloud, is the huge advantages over under vegetation, that even dense cover, you can get that topo very fast. And if you do it right with proper base station correction and processing, you can get a very accurate topography. That's right, there is another one. And volume, we actually just covered a lot of that. Volumetrics is another one. With the point cloud, literally can, in many software, you can draw a box. It's going to tell you, okay, this is how much volume we need to move and deal with. And archaeology is another one, right? Archaeology is actually probably one of the things that made LiDAR popular to many average people, is those History Channel documentaries using drone LiDAR actually discovered there's ancient site. Is there any plans in the future to have SLAM aiding areas? Yes. John, that's an excellent question. And that is, I believe, not just us, I think many others are pursuing the same thing, is to fuse different data sources, SLAM included, and not only to make the system also capable of doing SLAM mapping where GNSS is not available, but also using output from SLAM as an input to the navigation to augment or fill in gaps where you lost GNSS. This is a very hot area of investigation. More about your question coming from Bethy. I know I have to make heading at all times, which it seems like it would help, and Joe would increase the maximum time. Yes. Dual antenna, with dual antenna set up, it gives you the GNSS compassing. Yes, that gives you heading. And right there, yes, it's a huge help. And it is something you may want to consider. And like this example right here, David has, and this one I have here as well. For Recipe, for example, you do have the dual antenna option. Here you can plug in two antennas. For drone mapping, however, unless you are doing projects like you have to perform extended same direction, constant speed cruising, that's when your IMU is going to start to drift. Where IMU starts to drift, no matter how good it is, right? So they're going to drift. Once you have that drift happening with that dual antenna setup and low speed, you're likely to have a better trajectory resolution than single antenna right there. But we oftentimes recommend the dual antenna, not really for drone operation. That drift, again, like there are things you can do to help kind of deal with that situation. For example, incorporating dynamic maneuvers, acceleration, deceleration, figure eights, once in a while to wipe out, kind of bring back that drift. We typically recommend the dual antenna option. Is it does give you a better velocity estimate. So some countries, like in Japan, they have very strict, specific definition of every single spec. So the dual antenna setup in our case, I could be wrong here, but it's likely to give you the reliable outcome of that to hit that velocity requirement. But other than that, we typically would recommend the dual antenna option if you do plan to use your system for mobile mapping on the ground. That's where your GNSS signal is going to be quite challenged, and having dual antenna configuration should be quite helpful in itself. All right. But again, so for drone, typical for most customers, you probably don't necessarily need that dual antenna. It does cost a little bit more, and the setup is a little more complex. You do need to not just pack 2 antennas. I see, examples where they just put 2 antennas on top of M300. That gives you 50 centimeter or whatever maximum baseline, and that's probably not going to help you that much. But baseline meaning the distance between the 2 antenna GNS antennas. You need to achieve, depending on your INS, you do need to achieve certain level of baseline separation in order to really give you that advantage. So in our case, we recommend 1.5 meters. So that's about 3.5 feet. In order, so your 2 antennas need to be separated from, away from each other, for 4.5 feet in order to give you that really good, solid, additional heading estimate accuracy. And I've learned a lot. We flew 7 months collecting data on project that had completed conventional survey. Thank you. But I see a lot of Josh's, and I connected John as well, and Brad. I see a lot of familiar names. So please do not hesitate to ask any question, unless this is IP sensitivity or some business confidential information. I will share anything and everything with you, and even if it's something that we can do, I'll tell you, what other options that may be able to do that. Civil engineer firm looking to incorporate drone LiDAR technology and LiDAR into the service offering. Well, that is a really good question. Very open questions. I think going back to the same, key kind of a foundation of this investigation is, and there are many things. I'm not a civil engineer, so if anything I see about it is incorrect, forgive me and correct me. I think going back to, what are the projects your team plan to do, and what are the required performance specs you need from that system. So start there. Once you have those, that requirement list, then you can start looking into the options available in the market today. The options are abundant. Do you need to spend $150K for one of the high-end big systems? Maybe not, because I personally classify the LiDAR system as engineering grade, survey grade, mapping grade, and everything else. So do you need to get into that engineering grade? Is based on your assessment of the type of projects you want to do, and those typically cost quite a bit more. And so that's the investigation. And after that, as a part of your business, when you're looking at a few different options available, everything else being equal, let me just say this, there's so many options out there today. Higher price does not necessarily mean better performance. And lower price does not necessarily mean it's going to be good enough for you. So you do have to investigate. So look at your business plan, your project needs, then look at options available. Besides the value question, relates to your ROI, the major question I do have to point out is support. This is often overlooked. Training and support, it's really important. And Connor and I were just dealing with some of that situation right now. Yes, LiDAR systems, compared to even 3 years ago, the solutions available today are much more user-friendly. You can plug it in and do some simple planning, off you go. Yes, that is true. But whether you're going to get the accurate results that your projects require is a whole nother question. So you do need to understand and get some training, like how this thing works. Even better, learn, digging a little bit better how this technology works. A lot of things we talk about today is how the laser work, how the IMU work, how the GNSs work, and what's the different behavior, and different, depending on how you fly that system, all will have an impact on your outcome. So investigate a little bit of resources into training is another one. This is the slide I typically use when I share with a prospect or somebody who is interested in learning. Okay, what do I need to look for? It's not really as simple as you may think. Maybe the product offering is positioned as very simple, but the ins and outs are actually complex. So these are all the factors that can affect your final outcome. So the system, the hardware itself, and the operation itself. Good news is today, if you're getting a good system from a reputable manufacturer, your system should be capable of delivering the results. And another note, the similar systems from all the reputable providers are likely to deliver or achieve about the same level of results. And there's some difference here and there, different aspects, especially in the UX side, the ease of use. But otherwise, in terms of the final results they can achieve, assuming you follow all their respective SOPs, this should be very similar. So there's nobody that's really so much better than others. I would say no. But that's more you need to look at the low end stuff, the super cheap stuff, and products out there today. Some of them really do not work, and so you're gonna be careful there. So all these factors you take into consideration. So besides that, let's see what others you have to consider for civil engineering. I was talking about support. Yes, you should get some training. Dedicates at least one person to really dig deep into how this thing works, and you want to make sure you have easy access, quick access to support from the manufacturer if something goes wrong. It will happen, and for one reason or another. And so when you have a problem, you're running a business, you have a system that maybe the only system that's not functioning, and are you going to be quickly get the support from the manufacturer, be it drone, be it payload? Where are they? Are they in the US? Are they somewhere else? How quickly can you get the support? Do you have somebody you talk to? Is something you probably should consider as well. So I think that's most of it. Looks like very interesting. What data can we get? What data can we get? What can business customer do with that data? Yes, and so AJ, so you're thinking about starting a new business. Yes, so the data you can provide is really, I would say the number one use case is still topo survey. And it's topo survey. So you may want to talk to the surveyors in your region. Some of them may want to start, utilizing LiDAR technology, but they are not quite ready yet to invest their own resources yet. So flying point cloud, they're likely to have somebody who can already process the data. All you need to deliver them is a good raw capturing. But if you want to take it a little bit deeper, do the data processing and give them the deliverables, that's a lot more value than just a raw point cloud. For your utility companies in your region as well, it's the same thing. We are seeing a clear increased adoption of LiDAR drone LiDAR solution for power line use cases. And maybe some of them in your region would like to collect some data and they don't yet have that capacity in-house. Maybe you can do the data collection for them. When I used to work for the U.S. Forest Service, and we spend a lot of money hiring local contractors fly LiDAR data for us. So it's really so many use cases, but I would say that the easiest place to look at is topo survey. Talk to your survey companies in the region. Triple return and dual return, John. Yes, you can. That is an option, and most manufacturers would have that option for you in the firmware. Typically, in the payload GUI, you can graphic user interface. You can switch back and forth from dual return to triple return. Related to that question, when do you want dual return? When do a triple return? Triple returns can give you so much more data and better results under vegetation. But at the same time, triple return is likely to give you a little bit more noise. And one other note is triple return does not necessarily give you more data, because if your site is mostly like parking lot, it's a single high reflectivity service. You just don't get those additional returns. So it's the laser needs to be able to hit multiple targets along the way and come back, be registered. So that yes, you can. How does the precision accuracy result in point cloud compare to that of more traditional laser scanner? Oh, that's an excellent question. I assume by traditional laser scanner, we are talking about either static scanners or large systems like the big Regos and big Telidans. And the static scanners, it's a super mature, very mature technology. They are very, very precise and very accurate individually. And one thing I do have to say with the static scanning solution is because of occlusion problem, for a site, you have to scan multiple locations. So when you start merging the data from multiple scans, you're introducing a source of error, that merging, that registration error. So once you're done with everything, whether your global accuracy is so much better as like you have in the individual scan, it's hard to say. It's a big debate. Really, this one's between mobile SLAM solution and static scanner. So between the auto grade laser and the traditional big lasers from Rigo and Teledan, yes, I have to say the big systems are still better, especially big systems, the big Rigos, the big Teledan like the CL360. Yeah, they're much more precise and much more accurate. But the question is, do you need that really extra level of precision? For example, the Teledan CL360, it really can give you half centimeter precision, and even better than that. It's ridiculous when you look at the raw data. But if you're doing topo survey, once you've done the ground points classification, outlier removal, all that, will that be any different from a 1 centimeter level precision laser? Maybe not. But to your question, yes, the large traditional laser scanners are still better, but they may be too much of an overkill for a lot of projects. And by the way, those systems are designed to fly at high altitude. That's why they're super accurate, super accurate. Again, simple math. When you're flying drones much lower, much closer, that precision curve, you're at a different place on that precision curve. So you may actually be able to achieve much a very close result compared to the traditional laser. Typical automatic laser cost. Yeah. Yes. Okay. This is this goes to one of the sensitive questions, but I have no problem answering this one. Yes. So a lot of times there's still those in our industry trying to overprice the system, but what is overpricing is a very subjective question. I think so much information is out there today. You can contact the laser company, the IMU company, the receiver company, the antenna company. You can figure out pretty much the cost of most of the components, right? A lot of customers do this. They come to us and say, "Hey, I added everything up. It's this much." And why, so the first thing to mention is, and once we get down to the sub 50K range or even sub 30K range, the biggest cost item is your IMU. It's not the laser, it's the IMU. IMU is still pretty high priced. You can again reach out to this companies to ask for the price of this INS. Really, in this case, typically it's IMU and the GNS receiver, right? A good one, I would say, I probably shouldn't name the name or the brand, but you are likely to get for some very popular names. It's usually looking at anywhere from 9K to 15K, even higher, 25K, just for that INS. So you do that, you add up the cost of the laser, the camera, and everything. And DJI is able to achieve super low price for a few reasons. Number one, DJI controls everything in that system. The laser, the camera, I'm not quite sure about the IMU, but they control a lot of that. And so that allows them to already bring down the cost, because every component coming in there's different levels of markup and we have to source it from somewhere. Connor can talk a lot about this. He builds that drone, and there's markups along the way, so that adds up the cost already. And then you have to factor in, any manufacturers needs to make some money for themselves, right? So and so you take that all, and then you also have to look at each company's go-to-market strategy. Is it direct to market or is it channel-based go-to-market strategy, right? So if it's direct to market, that enables you to lower the price because you don't have to add that additional markup for the dealers, your channel. However, that means you're losing the access to your customer because it's a trade-off. Is the products today in our industry already so reliable, so easy to use that you can just buy it from Amazon? I'm not sure. I don't really take a side on this question, but that's another layer of cost. So that all these factors coming together is going to give you what is that MSRP you have in the marketplace today. So unfortunately, that's how it works. But but I do believe the overall cost of technology, like most technology, it's going to go down. It's going to go down, and it's probably going to accelerate at some point. And DJI has another advantage is it's got a volume very easily. When DJI launches some new product, they're launching that market immediately worldwide. Just by loading up the dealers, they're sending a lot of units. And right there is giving them the advantage, and also the cost of manufacturing. And I think there's no surprise there. And the hard fact is, in the drone LiDAR space, I think DJI is likely the only company that's actually manufacturing all those products at an industrial scale. It's actually a production line, automated everything. All right. So the cost of manufacturing individual unit is much lower. But for most the rest of us, we are still making one at a time. So that cost of manufacturing is higher as well. So that's a general kind of pricing cost structure for our product. So that I hope that helps to explain, the cost, why it's higher than it should be. Maybe that's the way to put it. Yes, windshields. There's a popular question. The windshields, yes, it's gonna create the noise itself. Can service be filtered? Yes, you can filter those out actually, and most commercially available post-processing software has this too. And even one simple noise filter can effectively eliminate most of the noises. And so not too much to worry about. If there's anything to worry about is you have large glasses, and it's going to have this mirror effect, and it's got a blob of points on the other side. Those may require you to remove them manually in the software. Just select them and delete those points. Yeah. Okay. Finally, this question. I was expecting this question. Again, explain my experience with a ban on certain drones for using federal contracts versus what payloads allowed. Yeah, this is so, Connor, feel free to chime in. And this is a very hot and heated question. And I'll say my opinions first. I've been living in the Bay Area for many years, so I personally, I have this tech startup mentality. So I would say ultimately we have to compete on product. So that's the foundation. Not everything else may matter, but should they matter? I would say probably not. And if you want to compete on product, compete on value. So that's what we want to focus on, and we do our best to make our products as good as possible. It's by no means perfect. We always have bugs and issues, but the governments are doing all these things. It's a much bigger game than we can control. I don't support it, but I can understand some of the rationale behind it. But I again go back to what we can do is compete on product. We focus on developing product as good as possible, and try not to. I don't take the at least the opinion like, oh great, now we have this opportunity because everything we make is at least finally assembled in Virginia. Yes, uh, it is to our advantage, but I don't want our products compete based on that. So that's my opinion. Connor, you probably have some take on this one
Yeah,
too.
I'm the same way here. We design our products to outperform the next guy. We're not trying to just make a product because it's U.S. buy it. No, we have clear factors that make us advantageous to using DJI or something else. And uh, who knows how long this, it might last forever. It might last 2 years. So from our perspective, we're not looking at the government ban as to how we make our products. We look at who's the top dog and what do we need to do to beat them. So uh, that's kind of Whisper's standpoint from a drone perspective. Uh, is how do we beat DJI in each of these applications, with LiDAR and mapping kind of being our strong focus right now, is how can we beat them in this space and move into other applications long term.
Yeah, to Brian's question, this is a really good one. This is looking at this situation from your perspective. If you are getting ready to invest into this technology and purchasing all these products, be it drone, be it payload and software, whatever, do I think you can safely invest in DJI moving forward? Uh, Again, this is a very, very sensitive question. I know that people take very strong opinion on this one, and I would say, thinking from your perspective, based on what I know and what I think the situation is going to evolve in the next, year, 2 year, 3 years, 5 years, whatever. I would say it is a fact that you have to think very hard. I don't think the situation is going to reverse itself anytime soon, and if anything, it's likely to get worse. So if your business involves providing services to government agencies at least, and now it's even universities, schools, local, agencies and government funded entities and utility sensitive utility sectors as well, I would say it's probably in your best interest to avoid this unnecessary risk, and then betting on it's not affecting you. And again, it relates to your business plan. And if you got enough jobs, opportunities lined up, with clients that don't have to worry about this factor, for example, a property developer or land surveyor in a region, you're probably fine. You probably can get this, investment back pretty fast and then move on. But in your business plan, it does involve providing services to the government, to the education system, to your local government agencies and even universities these days. I would say think twice about this one, and that's as far as I can see. Um, yes, Army Corps is definitely, and we know a lot of other private entities out really trying to avoid getting in trouble with this particular regulation because it's really gray. It's not so clearly defined. Connor told me some stories about just to find some waiver, and it's like from from this time to next time, just different, and nobody knows where that line is. But from your perspective, my recommendation is if you have enough opportunities lined up that can recoup your investment into this package, without having to ever deal with this factor, fast enough, by all means choose whatever that works best for you. But if your business plan does involve working with clients that may have to consider this factor, you should take in consideration this factor.
Yeah, and I could say just from the cost perspective, I mean, from a U.S. manufacturing, uh, you know, it's a huge expense on a manufacturer to be blue, green, U.S. Army Corps waiver. We've got one of those. Each one of those changes every 6 to 12 months. You have to do it regularly, and it's a huge expense on the
Yeah,
company. So it's not really fair to us as well, to
yeah,
have to meet all these extra DoD compliances when it's not relevant to what the users are using it for. It's not even a safety concern. So,
yeah.
but it is. We've got to, the rules are what they are right now. We just have to eat that cost, eat that, and move forward until we can see how it goes in the next 6 months. So
Yeah. So the question Yusuf has, what software do you all use for processing post-process your data? Now for the LiDAR side, and so you're looking at, I classify the software workflow into two stages. One is that, pre-processing or raw processing is where you convert all the raw data, the laser scan, the GNSS, the IMU, the camera images into, in the end, a georeferenced colorized point cloud. That's the first phase. And then once you have the point cloud, you take that point cloud, you process it, and generate those deliverables, be it topo surface or tree height model or whatnot, or the power line delineations. So in our case, in Recipe, and the first phase, and we develop most of it ourselves, initial labs, except the PBK engine, which is IE which we use. Full disclosure, we got nothing to hide. If it's from us, it's from us. If it's not from us, it's not from us. And we don't need to hide anything. So besides that IE everything else is developed by Initial Labs. And so that's the software package that's gonna deal with that raw, all the raw data set, inputs, streams, and convert it into colorized georeferenced point cloud. And we don't do anything from that point on. Once you have the colorized georeferenced point cloud, we don't even, at this point, we don't even do any optimization. This is one opportunity for me to mention this. Currently in our workflow, we don't apply any optimization. This is something you may want to pay attention to, because I know this is the place, there's a lot of interesting information out there. It's like, our data is so much better than others. But I think, optimization we're talking about, once you have the raw output point cloud, then you can do noise filter, outlier filter, and then even further smoothing to make that point cloud, better and better looking. Is it better in terms of quality? Questionable. Maybe not. Some of the processing may affect it, may not affect your data, quality at all. Some of them may. So we don't do any of that currently. And there are lots of software out there. So typically in the US, the popular choices for post-processing, I would say, Global Mapper and Carlson 3D Point Cloud. And TerraSolid is always top on the list, right? Others like TopoDot and a bunch of others and are available. And there are more and more online cloud-based processing options already. So the choices are abundant. So again, from Initial Labs, we don't go that far. Our workflow, our software stops at producing that raw, georeferenced, colorized point cloud in either LAS or LAZ format. That's where workflow stops. Okay. Any other questions? Let's see. I saw another question. I love questions like this, Josh. Thank you. Well, depending on how you define at the same time, I say if you have two full packages, yes, by all means, as long as you make sure plan them don't collide into each other, yes. And then you can send the data in our software. We have the batch processor, you process them at the same time, and you have the option to merge them already. So your data should come out just all right. But if you're taking it one step further, by the way, is it those two individual systems are actually somehow communicating, talking to each other, with the data actually be centrally managed somehow? We are not there yet, but interestingly, I say this question is interesting. Yes, we are thinking about this. And what if you have multiple systems, multiple sensors, and it's just like, how can we really make them work together? Because they are use cases that could become valuable. I'll give you a little hint. Again, you go to Initial Labs website, you see, certain sectors, Initial Labs is in for certain sectors, that feature can be quite important. So, okay, what's the next question? Yes, Swarm LiDAR, correct. And it's also a navigation. And it's worth to mention that Recipe is not just a full system. Recipe is a platform. Our own IP is a little thing in the middle. So now we don't make the camera, we don't make the laser, we don't even make the adapter. What we make is this little thing in the middle. That's our IP. So this is essentially very much the same stack of technology for self-driving and a lot of robotics applications. This is part of your data perception stack. So yeah, so that's why this can expand into other interesting use cases. Enterprise with UDL. Yeah, I would say so. Yeah, this is the same situation. I knew it was gonna get popular. It is something. If you are for the first time actually investing into your own business, starting something, again, go back to your business plan. If you don't think you're ever gonna, at least for the period where you expect to get your ROI and get your investment back, you are not likely to run into those projects. Don't worry about it. But if your business plan involves providing services to those clients who may actually look at this particular policy, you should take that into consideration. So it's really, really India distributor. We do have a partner in India, DI Labs, and so it's Delta India Labs, LABS. So they are based in India. Yes. Where would Slime? Nick, that's a great question. I want to say what I'm about to say very, very carefully, and because sometimes it could be misinterpreted. And all recipe systems currently shipping are SLAM ready. Now, what does that mean? Is if you have a recipe system, we have already officially implemented that firmware that will allow you to collect the data in completely GNS denied situation. Otherwise, you have to have to wait until the INS is fully calibrated. You got a GNS lock and all that. But we already implemented a firmware where you can go ahead and start collecting data with all recipes as if it was a SLAM system. But what we are missing today, I want to be very open and very clear, is we don't yet have our own SLAM software. So once you have the raw data, you still need to process the raw scan data into a point cloud that requires a SLAM. That's what we don't have, so that's where we are. And I hope that helps. I know it's a little gray, Nick, and sorry about that, but I'll just leave it at that. Which one is the one with the best precision? Everything else being equal, the best precision is achieved with the CL360, which is a new product we're about to launch. That's the most precise. Again, that's a laser from Teledyne Optech. You can look it up. There's nothing to hide. And the precision you're looking at when everything else being equal is the laser itself. So the CL360 is from Teledyne Optech. It's a really precise laser. Even at very long range. After that, between XT32 and M2X, it's really strange. I would have to say, be 100% honest, the XT32 is more precise slightly than the XT32. Again, I think it's because they're trying to pack a lot of more power into a smaller form factor and shooting out more laser and bringing that triple return, and all that can bring in some uncertainty in that measurement itself. But interestingly, one optimization thing you can do is noise filter. And depending on the particular software, which algorithm they use, noise filter may not actually physically change the position of your points, assuming that's the algorithm. So in that case, noise filter is not a problem, except it may wipe out a lot of points. For example, for power line, now you're losing power line points or smaller feature. But assuming it's a flat ground and between the XT32 and once you've done that 1 sigma noise filter, they're about the same. There's really no difference. So that's that's the most precise one. We are working really hard with Oster as well. Thank you. Really many thanks to the Oster team. We're looking at the Rev 7 OS 164. It's a very promising laser, and we are working with their engineering team to really improve the accuracy as much as possible. So that's and beyond that, especially at anything beyond, beyond 50-ish meter, it's noisy. And so that's my answer. Others can get better, and it's just involves a little bit more processing, and maybe we did not do enough to work with the product, the laser companies to really get everything right, from timing to what corner system actually register is a native XYZ, or it's pure raw measurement of distance and angle. They're all things they can do, and what I can tell you is yeah, that's where we are. Mobile tablet, any from us? No. We are that's for that one is really more a software startup question, and there are quite a few of those out there already, and I know a few of them. So utilizing the laser on board, for example, the power, the iPhone, the iPad, those are getting really interesting, and I'm in touch with a few of them, and I think give them some time. They can actually be quite useful. Like you want to do a quick scan of, I don't know, like one room type of thing. That laser range is pretty limited. You just don't have enough power to send the laser far enough and maintain that accuracy. So expect that. But combine that with that really good camera on those phones or the tablets, you can really get pretty good results. But no, we are not getting there. How much power consumption? I want to double check the spec sheets to get a number right, but what I can tell you is, Connor, you might even know it, but otherwise it's not much for the payload.
Yes, our collision avoidance on the Whisper Ranger Pro is a LiDAR based collision avoidance, so it'll work in night or daytime. It doesn't matter. It's going to pick it up.
All right. So Nick, is another question. Can't get data file created to work on this global mapper. I think you're asking, the data file maybe from Recipe, the raw one. Yeah, that one you cannot. That one needs to be processed through our software. That's the raw pre-processing stage. You have to send that through our software. Generate those standard point cloud format, LS, LZ, or whatnot, before you can take that data into something like Global Mapper. I'll data set for beautiful question. My wish, if I go back to my old days, remember the example I mentioned about mapping the tropical islands, and I was desperately looking for a good topo. Believe me, I mean, some of you may not remember those days. It was tough. I wish there was. U.S. has done fantastic job, probably better than most country, with all those publicly available data sets like land cover and that kind of stuff. And I wish that they will come soon. How are we gonna get there? I think I don't know. It's a very large country and so much to capture. But I think you look at the interesting places to look at to make this possible is not really us or surveyors or even the government agencies or research entities. It's probably the companies like Google, Apple, for their mapping on self-driving purposes are likely to capture LiDAR included. And photo as well for more and more areas. But there's also becoming a little a new startup area is the SaaS companies providing platform that where you can upload data and maybe even make it shareable and get some return from sharing those data. Those startups may offer another possibility of getting to the point where we have as much LiDAR coverage for the country as possible. But I would personally very much hope that day come here, soon. Okay. What other questions or excellent questions? Thank you guys so much, and this is wonderful, and I hope I'm helping you guys to get more from this. As for the own post-process software, that's excellent questions. At this point, no. Post-processing software is not, it's pretty complex. And we are at core a hardware company. Our core competency is navigation. It's IMU, it's INS, and other navigation sensors and solutions. Uh, we are, at least I can tell, what I can tell you now is we have no plan to develop post-processing software. So we are looking, we are partnering with software companies to provide that total solution to end customers. So okay, any other questions? Did I miss anything? From Google, what is a process called for identifying the best fitting simple flap? What is a process called for identifying the best fitting? What is a process called for a surface to a setup? I think best fitting plan and or best fitting surface is already kind of what it's called in the research community. I'm not sure if it's referring to a specific function in a software. Best fitting simple flat plan to a setup. Yeah, that's kind of already typically called the best fitting surface. Is typically the software going to region by region analyze all the points in that region and try to generate a statistical understanding of the distance and where that statistical center is, and then try to link up all those key points and generate that surface line or surface or not, or even, so that's already there. How do I convert point cloud to 3D models? Oh, it's probably similarly related to how do I convert a LiDAR point cloud to a mesh. It's I I'm not sure, because that's more on the BIM side. People do a lot of that with the mobile scanners. I'm not qualified really to answer that question, but with my limited knowledge, talking to others, and something like a context capture or something like that might be, options. But whether they're good, how good they are, I don't really know. I'm sorry, but I haven't touched that space for a long time. Control checkpoints used for programs. Well, can you touch on how this can? Yes, David, this is a really good question. Especially in the early days, there was a strong kind of promotion saying that for LiDAR systems, you don't need ground control. I would have to say, no, don't do that. Probably shouldn't. If your LiDAR system is really, really good, it's built to achieve this level of accuracy and precision, and you perform that project absolutely right every single step, placing your base, measuring your base height and conducting all the calibration maneuvers, your LiDAR point cloud should come out actually very accurate. However, that said, there's so many things in this workflow that could not go wrong, but go imperfect. In other words, for example, your base, your base is not on a survey monument. Right there is a big problem, and which could be, if you look at NOAA's website, it could be, I don't know, I don't remember precisely, like 6 feet off or something, or some one of those little things, that's not done perfectly. Your point cloud is likely to have some sort of more or less of hopefully a systematic offset. That is not a problem. Don't worry about it. I believe even in ASPIS standard, especially on the aerial side, there's one step called debiasing. That's when you use a small set of control points to tie in your point cloud systematically. Hopefully you don't have to do transformation and rubber sheeting systematically to those control points before you use checkpoints to actually analyze your accuracy. So having a few really, really accurate controls and use those to tie in your point cloud, even though your system is really good, I would say it's a very good practice to do. And then you use the checkpoints to do that. And then the next level of question is how many controls you need to use, how many checks you need to use. That numbers vary very much. And the controls, assuming you don't need to do any nonlinear transformation. If you look at 3D space, 3 points is in hope, unless they're on a line or something, they're enough. But 3 or 4 maybe is good to tie in your point cloud systematically by to actual accurate absolute reference system. And checkpoints, it's variable. I actually once wrote a paper about how many accuracy assessment samples you need for classification. And statistically speaking, I'm getting a little bit nerdy here. Statistically speaking, the number of checkpoints you're going to need in order to achieve that robust scientific accuracy number is, for most projects, it's impossible to achieve. Believe me, if you run the number is pretty high. But in the previous ASPIS standard, the 1.4 version, I believe I'm not 1.4, sorry, 2014 version. I believe
20 per 500 acres.
Correct. And in the new one that's about to be released, I think this number is raised. Is now recommending, I believe it's going to be 30 checkpoints. But again, the interesting with LiDAR is assuming you have a good system, and any changes, adjustments should be linear, except for SLAM system. It should be linear, meaning, you really should only need a much smaller number of numbers to verify the accuracy. But in the end, it's your client, the surveyor firm or whatever firm, they want to say, hey, I need 25 checkpoints. They may even provide you with those checkpoints to assess the quality. So that's the one. But yeah, I want to make it very clear. I do recommend use a few controls to tie in your point cloud. Regardless, you may not need to do anything. If you do everything right with the base, with the correction, with the processing, with the flight, the point cloud may just show up tying just perfectly already, or not by much. That means you don't have to do anything, but performing that step is probably a recommended thing to do, for that. Best GCP targets for LiDAR. Traffic signs a good one. LiDAR, when you do accuracy assessments with LiDAR, one thing to keep in mind is don't use a colorized version, use the intensity. Because the colorization, the RGB colorization is unlikely to be perfect. If you switch between the display by intensity and RGB, they are likely to have more or less of a offset, which is expected, because projecting a 2D image to a 3D point cloud perfectly is very, very difficult to do. So when it comes to identifying the precise position or location of a specific point in the point cloud, you should switch back to the intensity display and use that as your assessment base. So therefore, the choice of GCP targets, you want the targets to give you the best possible of intensity capture. So high reflectivity. Oh, that's a good one. Size-wise, 24 by 24 is probably good. The larger obviously is a little bit easier, especially flying high, and sometimes it's difficult to really pin down that one point, one location. If you have a larger target, sometimes you can do is kind of do a little bit of draw two lines and find that cross of that center. But high reflectivity and a very popular thing, a lot of people I know they do is that they paint. They use some sort of paint on like a hard surface, flat surface. Those can work quite well as well. But those commercially available, those market probably will be better. It will be pretty good. Black or white is totally fine. I did read a paper by somebody. They compared a different color, red, yellow, blue, and the green, and black and white, and see which one works better. It was a really interesting paper. Whether I agree with that finding doesn't matter, but you can probably I think somebody in the Josh and the others community already provided answer. They typically should work pretty well, so I use GCPs for every flight, even if just to check myself. Data accuracy means customer return. Absolutely. And this is what I always want to say is if you're starting a business for yourself, providing LiDAR service to your end customers, believe you got to always think, what are the customers buying, right? They're buying some sort of either the raw point cloud, hopefully as accurate as possible, or deliverables also as accurate as possible. And you want to build that, credibility. And so you want your data to be as accurate as possible. And utilizing GCP is one of the things you probably should do to avoid unnecessary, missteps, so to speak. And it doesn't take a lot with the RTK system today. You can collect those pretty fast. And if the project is relatively small, and you do, I do agree and collect GCPs.
Every single LiDAR flight, we suggest getting ground control points, at least for verification of yourself, but
yeah,
to prove the accuracy.
Oh, 10 triangulated regard is the name of the surface on mesh created from. Yes, 10 model is one way to model a 3D surface, and the most software will have that too. As well. And the deliverables in the GIS world, again, that's my background, and 10 is still very popular. But I personally is more a fan of a raster. I used to write a lot of script myself, and raster is in many ways a little bit easier to work with for scripts. But that might have changed. That's a long time ago. So any other question? Have you checked out Prost? No, I'm sorry, Brenda, I have not checked that software myself. Especially, yes, it's all on our website, and you can download those specs. And I'm sure for Connor, the website has those information is available. Yes, all public. The specs of the recipe system as a system, and the specs for the IMU or IS we use inside because we make it. It's all out there for download, and so you can get those from our website. Let's see. I think I did miss some questions. I was trying to scroll back to the questions and trying to make sure I didn't miss anything.
Nicholas asking if for a demo.
It's the work
with question.
Demo some of the data of your data. Oh, you want a demo now in this webinar? I'm not sure, David. Do you think? I'm not sure if that's easily doable. Well, David is investigating. Yeah, so I know we have possibly a lot of. Yeah, I already talked about this one. Yeah, we have I do know we have a lot of new adopters coming to the LiDAR field. What I do want to say is, again, in this phase of this technology, this market, the products are so much better than even 3 years ago. So much better and so much more reliable, more affordable, and the better UX in every way than 3 years ago, even 2 years ago. And it looks like that improvement velocity is accelerating. But if you are not coming, I want to be very careful what I say here. It is still fundamentally a complex science. So if you're not coming from a background of either survey, remote sensing, or GIS, you should investigate a little bit more time learning about this technology first before you jump into it. Trying to get understanding of how everything works, how the different components come together, the base, the payload, the drone, the mission planning, the processing, the optimization process, how every step, will affect your result. I would say it's a worthy investment of your time. All the information you need is out there. Just Google. A lot of that is already there. Very good information. What you may want to avoid is jumping in, maybe thinking the system is so easy enough, but we have seen so many cases. Simple missteps in performing a project will cause you a lot of trouble. And that's unnecessary. And there are things you have to pay attention to in that whole process from hardware to processing. It's worth the investment. It's really your time. And then from product to product, once you have that understanding, then you can better choose the best product for you based on your business plan for the next several years. All right. Any
So I
other
think
questions?
we had Josh here. I don't know if that was, you wanted to elaborate a little bit, but we'll give you a second to retype that. Looks like you erased it on your end, but that's almost at the 2 hour mark, hour 55, and I think we ran out of questions.
Okay,
So,
that's perfect. Yeah, I just want to say we have a very vibrant community today. It's really exciting, and there's so many good people out there trying to help our community to move forward in their own way, one way or another. They're putting out so much good information, use cases, examples. It's really exciting to see the evolution of this industry. So I'm very happy to be part of it.
so we'll let you take this last one, Connor.
Yeah, so the Ranger Pro is it's built to carry 6-pound payloads, and it can handle 50-mile-an-hour winds and still run successful missions. It's got hot swappable batteries, 360 collision avoidance, and it's smoothly integrated with inertial labs and pretty much any LiDAR. You can attach it, plug and play, and kind of go. We write all our own software and a lot more things. We could go on for days, but really more specifics on what all questions you have about the platform, we can answer it.
Yeah.
When I was supposed to come see Josh here next week or so, so I'll answer all
Yeah.
those for you too.
Do we still have any road tide out there?
Not this. The questions that people are talking about the arrow points, propeller arrow points are solid. I'll say that we like those, and we work with those guys, starting to get a little closer with propellers. So I do know they're working on some things software wise that will pertain to LiDAR. I just don't know when that will come, but arrow points are awesome, as you stated.
Yeah. Well, I'm sure in the future we'll have more kind of more focused, webinars if you all are interested in, for topographic projects, for power line projects, specifically, and we want to do anything we can to help out everybody. Securing the drone and the LiDAR. Maybe hinting a parachute. Quite a few of those out there already.
Yeah.
Anybody have any suggestions on the next webinar we could do? If you have any comments on that, feel free to send any of us a message. We're happy to help. We want to help the community best we can.
Yep.
So we're right at the 2 hour mark now. So thank you all. We really appreciate it. If you have any follow-up questions, get a hold of myself or the rest of us. Looks like last thing.
Insurance policy. Yes, as insurance policy, just cover this quickly. Yes, there are insurance policies out there. There are two ways to insure it, and usually double check though. Your general business insurance might already cover it, unless your underwriter requires something special. But otherwise, your general business insurance should be able to cover it. Again, check with your underwriter, insurance provider. Yeah. All right.
Thanks everybody, and we'll see you in the next one.
Thank you.